Hi, this is Alex from devstories.eu. Prompt Flow, the Complete Guide, Episode 7 of 14. You might think that using a specialized framework for large language models means learning a complex visual interface or maintaining massive configuration files. But if you already know how to write a Python script, you already know enough to build a fully trackable application. Function-based flex flows resolve this tension entirely. In standard prompt flow development, you build a directed acyclic graph. That structure is highly effective for strict, multi-step pipelines, but sometimes developers want to write pure Python code without adapting to a visual node system. Flex flows allow you to do exactly that. You encapsulate your LLM application logic inside standard Python functions, and the platform handles the tracking and orchestration in the background. Consider the function-based approach. You start by writing a normal Python function. Give it a descriptive name like chat, and define its inputs, such as taking a question as a string parameter. Inside this function, you write your logic just like you normally would. You might load a promptee file to get your system message, initialize your language model client, pass the question to the model, and then return the text response as a string. At this stage, you simply have a standard Python script. It runs locally, it is easy to test, and it requires no special framework knowledge. To turn this pure Python script into a trackable prompt flow component, you import the trace decorator from the prompt flow tracing package. You place this decorator directly above your chat function. When you run your code, this decorator tells the system to monitor the execution silently. It automatically records the inputs passed to the function, the text output returned, the exact execution time, and any internal errors. If you apply the trace decorator to other helper functions within your script, the system builds a complete call tree. You get the full observability of a visual flow, including the ability to view the execution trace in the local user interface without changing how you structure your logic. Now, the tooling needs a way to know that this specific function is the entry point of your application. You provide this by creating a single, very short configuration file called flow.flex.yaml in the same directory as your code. This file does not define a complex routing graph. It only needs one critical piece of information, which is the entry mapping. You write the word entry followed by the name of your Python module, a colon, and the name of your function. If your file is named app.py and your function is chat, your entry value is simply app:chat. When you test or run this flow using the prompt flow command line tool or the VS Code extension, the system reads that YAML file. It looks up the chat function in your app module, injects the provided inputs, runs your pure Python code, and collects the traces generated by the decorator. The real power of function-based flex flows is that they remove the friction between prototyping a script and deploying a production application. Your pure Python logic remains entirely under your control, while a single decorator and a two-line configuration file unlock enterprise-grade observability. That is all for this one. Thanks for listening and keep building.